Hello, welcome to our project where we have built a global power ranking model to rank League of Legends teams globally.
Yeah. These are all the AWS services that we use for our project. So for our project, we decided to structure our model by calculating the expected wins for each team. So essentially, for any given list of teams, we would put the teams up against each other in a round-robin style tournament. And from each matchup, we would generate the number of expected wins for each team. And the sum of the expected wins for each team would be used to rank the teams.
We calculated the cumulative stats for each team by getting the average of various team stats, such as average goal difference at 14 minutes. We gave heavier weighting to more recent games so that older games had less impact but weren't completely discarded. Our hope was that the model would decide on the importance of each feature we handpicked. We needed a simple model to serve as our performance baseline, so we trained a naive-based classifier. This allowed us to train and compare with more complex models in order to find ones that yielded more sophisticated and accurate predictions.
So the first thing we decided to do was use random forest as our first model to compare with naive Bayes. And in the process, we found that this model tended to favor wildcard teams who are dominant in their region. And so from that, we decided to make some changes to heavily weigh the international games, and we tried to also find optimal hyperparameters. But unfortunately, the model seemed to still struggle from that issue of heavily favoring these dominant minor region teams.
In search of a more performant model, we decided to try out a logistic regression model. For this, we first pre-processed the cumulative data by standardizing numeric values and one-hot encoding the categorical features. After that, we fine-tuned the model's hyperparameters with grid search cross-validation. Using the optimal hyperparameters we found, we checked the model's performance by calculating its accuracy using stratified k-fold cross-validation. The actual logic behind ranking generations is more or less the same as the random forest model, where each team plays every other team once. The outcomes of those games are then summed up to generate the expected wins for each team. And on top of that, we wanted the regional importance to be reflected, so we weighted international games more heavily during the training phase.
As a bonus, we decided to use our model to predict this year's Worlds 2023 tournament. And as you can see, we have predicted Gen G to be our winners for this year. So we will be keeping a close eye on them.
Hello, so this is our front end for our global power rankings hackathon for Riot and AWS. And currently, when we select discover your team, we are presented with three different features. And when we select tournament rankings, we can search a tournament. Let's say we do NALCS right now. The standings on the right is the actual standings of what happened during the summer 2023 LCS. Let's see how our model go against it. Right now I'm gonna choose logistic regression, and it expected evil geniuses to win. And let's go back to our other features. Now we're looking at custom rankings. I'm always curious to see how the number one seed of NA go against the whole LCK. So let's see how they do. We will select logistic regression once again. And it looks like Cloud9 will come last, unfortunately. And global rankings, we will save that for the judges.